I'm Mariangela Pellegrini. I'm from the ERN-EuroBloodNet. So I'm very honored and happy to introduce this webinar session that is a co-joint program of GenoMed4All and the ERN-EuroBloodNet. Indeed, this is the second, let's say, wave of a more comprehensive educational plan that started its journey in 2021 with the e-working for patients organization. Then we had last year 4 sessions dedicated for public at large, where the objective, the achievement so far, and the program of GenoMed4All was presented, together also with the explication of all the challenges and solutions that the artificial intelligence could provide to the hematological field. Is this program I'm going to present is as I said, the second wave, and it's foreseen for an expert audience, and it will consist indeed of six sessions that will start so today with the first one, the introductory one, and will be end the 23rd of October. So I hope to see with all of you this journey through the artificial intelligence and its application in hematology. So today is the first session, as I said, and we are going to see and learn the road so far of the project of GenoMed4All. With us, we have, well, a key speaker. So Federico Álvarez is also the coordinator of GenoMed4All. So I'm very glad and honored to introduce him to you. So he's a telecom engineer, and he works in Universidad Politécnica in Madrid, who is full professor in UPM in the area of media communication and application of artificial intelligence. He's also the coordinator in different EU programs like GenoMed4All, as I said, Rescuer, that is artificial intelligence for situation awareness, of first responder, EU for child, tender, and he has a full shining career. So I'm very honored to have with us Federico Álvarez. So the floor is yours. Thank you very much.
Thank you very much, Mariangela, for the nice introduction. Well, I'm simply the coordinator of a common, let's say, program, more than a project, a couple other sister projects that will continue, and that as well are in the, let's say, environment of EuroBloodNet. Today, I'm gonna give an introduction. I will explain the main topics that are addressed by the project, some of the results, some of the areas that can be interesting as well for collaboration, and last I will explain how is it possible to be part of GenoMed4All in the sense of more clinical partners that can bring and share experience, data, and knowledge with us. This is the different topics that we are going to address today. Of course, this is the first of the series. Then we will go in deep with some of these elements in next webinars. And today, of course, if you have questions, so please raise or write in the chat or something. If not, we can do it at the end, moderate by Gavin, of course. So first of all, I would like to have this introductory session. I'm the coordinator of GenoMed4All, and GenoMed4All is a project focused on the, let's say, use and analysis of genomics and clinical information under the umbrella of AI to solve some of the endpoints and unmet needs in different hematological diseases. Project started in 2021. We plan to finish 2024 at the end of this year, or if possible, to extend 6 months. But This project is into a program, and we are going to work with some other grants and initiatives that are already funded, are already in place. So therefore, what I'm telling you about the onboarding, of course, is a general thing for now and the future. The AI models are computed in high performance computing, and we started with 10 partners, and now we are enlarging the network to more sites. As I say, we're building a program, and results of what we are doing in terms of data platforms, algorithms, results, is what we'd like to share with the community of EuroBloodNet. Hematological diseases, as is understood and you know, have a strong genetic background. There are more than 450 variants between oncological and non-oncological diseases that are resulting in abnormalities in blood cells, lymphoid organs, coagulative factors, etc. And this kind of diseases, since they are, let's say, majority of them are rare, what's happening is that we need to, first of all, being able to gather as much as possible data from patients in Europe to start with. Accounting all of them, there are 5% of the cancers, and also cause chronic health issues. As well, we're talking about a big cost in terms of the disorders for the European society. There are two main issues to, let's say, boost the research. First is that, of course, the available samples remain small. And then the repositories, so the available information, is distributed. That means that this really, there's a lot of sparsity in the availability of information. What we want is to present solutions to them. So what we want is to, first of all, develop what we call a federated learning framework. Means that the patient data do not leave the clinical site. That's a secure environment where we can, let's say, train AI models. We can do distributed analysis. But as well, we are able to have ethical agreements, have all the legal parts solved, and present something that is according to European legislation and European values. In the sense of final, we can do cross-border data exchange and cross-border collaborative work. This is the only way that for the diseases that are rare, really we can then apply and get better results. If we still have this sparsity, we will lead to the scarcity of data, and then we are not going to advance. This is one of the first part that we are. And then what we have here is that we would like to connect repositories. But the repositories, it's important that as well they have high quality data. And a variety of omics, including genomics, is really relevant, as I said, because there's strong genomic footprint in many of the diseases. What we want is to really boost the adoption of open standards so we can provide data. We are providing tools for anonymization, for standardization of data, verification. And we want is to really, if this data is with open standards and it's possible to collaborate and compare data in different countries, in different repositories, even within a country. And what we want is really improve the accuracy in the markers for prognosis. We want to improve the results compared to the prior art. And as well, we'd like to reduce the time for AI. AI training, it's something that takes a lot of time. You need strong computing. And we'd like this as well, that we are providing HPC computing. So it's possible to train that models in a limited time. So we get faster and better results for the health researchers. Which are our focus areas? So we'd like to unleash the power of AI in the diagnosis, let's say identification of the high-risk individuals, prognosis, let's say the predictions for the site of how the disease will develop, And then the treatment on the clinical decisions, support models, research certification, and let's say help in understanding which is the best treatment. Some cases, for instance, some cases can be transplantation, some other cases, no. So these decisions that currently are done according to some standards, some guidelines, would like is to improve the way that they are done with more information, with better models, better certification, and better understanding of the insights. We are a group of, as I said, of different partners. First one is the Technical University of Madrid that I'm part of. But there are, as I say, 10 clinical sites that are part of our project. And let's say they are participating in 3 different use cases or diseases that I will describe later. The clinical partners you may recognize are the Humanitas, Valdebrón, APSP, MLL, UMC Utrecht, so maybe you are IPSAL, so you're recognizing some of them, Padova, Leipzig, the University of Athens. So let's say that the different partners that are in some cases, let's having clinical data providers, they are part of the data and understanding of data. With partners with expertise in AI, like CF4, Torino, let's say UPM, the University of Copenhagen. And as well, we have partners for, let's say, for the data platforms, Vedalus, Data Wizard, Value Healthcare, like Thermo Fisher, that is a very well-known device provider, equipment provider. Legal parts covered by that we had there, and some partners as well helping the repository like Cyprus and CRG on the genomic regulation side. So let's say that Cineca for the HPC. So all the partners that we are participating, as I say, these are the initial partners in the project, but we are in the way of enlarging with more clinical sites and participants there. The EuroBloodNet is very relevant for us. It's very relevant for this project, but very relevant for the sisters projects to really create something that is beyond a project, but start and will end. But what will remain is to these, let's say, partners, EuroBloodNet members that are more than 100 can benefit from their first participating there, okay? And since EuroBloodNet, this is European Reference Network for the rare hematological diseases, really, we need to find the different, let's say, organizations that can help. Since this is a joint effort between the European Hematology Association, the European Network on Rare and Congenital Anemias, EuroOrdis, some advocacy groups, all these together is a strong ecosystem to really build more than really a project, and build for the future something that will go to EuroBloodNet. So GenoMed results will be integrated in EuroBloodNet as software, as tools, as results, as repositories, as everything to support and improve the European research. What else? Okay, let's say that seeing under a global lens, rare diseases maybe are not actually rare because they impact small on paper. In reality, around 30 million people in the EU are living with a rare disease. We are talking about 300 million people worldwide. And so what we are devoting in the personal medicine for rare diseases of the solving the data scarcity, the data fragmentation, improving the way that so we keep the European values and regulation on the privacy, consent, and as well the data quality check and data quality provision. This is something can be extended to any other rare disease that okay, we'll comment on, but the European Rare Disease Partnership will as well benefit from this. And that's what we are doing is that this European partnership on rare diseases that started 1st September for the next 7 years, this having a similar for many other diseases issues that we are facing in this project. Our use cases coming more to the, let's say, to the examples that we have for this project, that of course can be generalized, as I'm saying, are white box AI models. So the models that we are developing are not going to be, let's say, closed models. We are going to provide that models. We are going to provide, in many cases, even the code, the weights. And so there we assure the replicability, and we're also giving something for the community. And what we are doing is that having the validation in for AI in hematological diseases will be done in 3 main use cases. First one, myelodysplastic syndromes that are a group of bone marrow failure disorder, typically affect the elderly. They suffer for some low blood cell count, since their bone marrow is no longer able to produce enough healthy blood cells. It's known as a pre or a form of a blood cancer, since the patient can evolve into acute myeloid leukemia, fatal if not treated. So the clinical aims that we develop, and I will show results and some publications. There's some of the let's say elements that have been studied, and I think that we got some results, are based on the prevention based on genomic screening, investigative factors to influence the development in early stage identification of the individuals. As well, we have the omics-based classification. Omics include from different biomarkers and genomic information, radiomics that put the images, and as to develop personalized predictive models. As well, with the omics, it's important as well to use them to understand and stratify individuals. This is very important to predict the response to specific treatments. Let's say that in many cases it's crucial to select the right treatment. And let's say the omics clinical AI analysis can lead to better treatments, better selection of treatments. It's important. And then something that is relevant is the drug repurposing, that there are, you may know, there a great amount of drugs for cancer, but it's possible to be repurposed. There's something that can indicate us there, so something that is as well on the study. Second one, coming to the non-oncological side, is the sickle cell disease. That is a group of hereditary red blood cell disorder. So this is hereditary, a strong genomic footprint, and it's a rare chronic life-threatening disease. The red blood cells become C-shaped, like sickle, and okay, this is named after. Sickle cell very early and try to clot the blood fluid. And the patients usually suffer from low red blood cell counts, infection, acute syndromes, and strokes. And well, the prediction, for instance, of silent infarct and the progressions, and some other is really something that are unmet needs that we need to contribute. So the clinical aims are from the gene mutations linked to inflammatory. As well, we have the risk profiles identification, allocation of patients to risk profile, done with some genomic annotated archives like EWALS. Develop combined models to predict clinical outcomes, for example, present renal damage, and AI-based radiomics. So say that the use of MRI image with the predict sudden infarction in young patients with clinical and AI information is some of the strongest studies that are undergoing there. And something that is a bit more prevalent, that is the multiple myeloma. That is a bone marrow cancer, originating plasma cells, and it's a type of white blood cell responsible for producing antibodies to fight off infections. So in patients with multiple myeloma, these cancer plasma cells accumulate in the bone marrow and produce abnormal proteins instead, again leading to decreases blood cell numbers, bone and kidney damage. In that case, first of all, one of the aims is to understand the complexity, let's say, genomics and imaging data, how they contribute, the corresponding variables, radiomics contributing there, with analysis of source segments in some bones. It's really relevant there. Evolution dynamics with the quantitative and qualitative dynamics of the disease in time, risk progression, developing risk scoring for prognosis, and how the disease remain after therapy. Last but not least is to integrate with radiogenomics. Radiogenomics, I mean radiomics and genomics together, but let's say not to study two things separated, but how they are, the combination, how they affect one to the other, and develop treatment response. And that's something that are some of the aims that we're already working the project in the last few years. Collection of data. Okay, let's go to the data collection. We are collecting from our partners and let's say associated partners and contributing to the registries. As I say, there are 20,000 patients with myeloid neoplasm. And yeah, there are more than 100 centers in EuroBloodNet participating. And with the diagnosis, we have that there are a few thousand with different the same kind of oncological syndromes, and that's the data that we are using for the studies. Second one, for the sickle cell disease case, it's done through Enroll. That is a platform that is the umbrella for both new and already existing registries on hematological diseases, and Enroll and avoiding fragmentation of data. So we don't want to prevent the wheel, and the data and information getting there, coming in collaboration with Enroll. And of course, Enroll is mapping the demographic survival rates and erythrocyte genetic information and all the manifestation. So it's pretty complete, really, with the data available on that disease. We'll have more information in. I don't want to, let's say, too much on the diseases, because you will have some specific training webinars in the next weeks. But at least, let's say, a new important, I think that's Radip, that is an initiative to pool data, registers with Enroll. So Radip contributes to Enroll by sharing a subset of patients' anonymized data, and the possibility to share and pool data to reach critical numbers. With critical numbers, you can perform clinical trials and projects. We generate knowledge, and of course, there's better care for that patients with rare anemia disorders. So, we are getting the data. Okay, we are getting registries, but again, it's anybody in EuroBloodNet also that would like to contribute. We will give the way to contribute. So, as I say, better numbers, better quality data, better trials, better research projects, better knowledge, at the end, better care. That is our ultimate goal. Going a bit more, let's say, on the way we are doing in our platform and something, going a bit more techy on the IT side. We are getting, let's say, different, let's say, data sources that we have here, and let's say, start by the data sources that we have. Different genomics, omics, and information from clinical science, trial and population, let's say all of them, are going to, let's say, our registries. These registries that we are, let's say, getting, we are having some sort of optimization, but as well, we are trying to link data with some standard features, that is the FEAR format. But as well, we are leading everything to OMAP in this transition. What does it mean? That the data that is collected is as well standardized. standardized means we share the same fields. Meaning we share the same fields means that we can compare, that we can combine. So we can, let's say, go to a platform where we can compute it. And this is where we are going there with an ethical AI approach that all data collection and the studies are following, of course, all privacy matters, all ethically aligned on. So the models are explained to the health professionals, so no black box at all. Okay, we have explainable models. And then we compute the models, okay? And what the result is that we are going to build new treatment and publishing. We are improving the clinical guidelines, and also we are going to comply with the, let's say, interoperability of data, accessibility of data. This is something we are going to follow as well. And this is, let's say, doing in a federated learning manner. That means that the data is not moved away from the original site. And all the half of the registries, let's say, the AI models that we have are computed with the, let's say, hospitals. The hospital data is not leaving there. So we expect that with that, more and more clinical sites can offer the opportunity to, let's say, share the data without moving away from the hospital. So we have two complementary operational modes for our federated learning platform. Okay, for clinicians, it's a local decision support system to input new prospective and retrospective patient data, extracting insights from every learning model. And for researchers, it's an AI workplace. So we can explore data sets, develop, test, and train new models with a federated learning environment, meaning that, as I said, the data is not moved away. So what we have? We can have the clinical. So we have pre-trained predictive model for clinicians and patients. So the clinicians extract data during patient visits, okay? Laboratory tests, fine. Input individual patient data into the platform, okay? Then the technical platform, we input that data. And the model offers a prediction of the patient health status interpreted by the clinicians, okay? The benefits is that we provide access to predictive algorithms. So let's say the algorithms developed in the GenoMed4All can be used for the daily practice. The architecture of federated learning is designed in such a way it's very natural to retrain the models with new data. So you bring new data, you can retrain your model to accommodate to that data. And support the personalization of the models. So let's say each individual patient, while also incorporating global information, is unique. So it's very important on that side. So let's say that this is a good benefit. And as well, the results of this new data training will be a global result for the rest of the patient and other sites. Going to the research mode, the retrospective secondary data, IT data, clinical data scientists, can perform an exploration of the local data to define these models. The data providers can upload the data to be transformed to our CDM, okay, following a CRF. And the predictive model is trained with the whole data set, with the local contributions. And that global predictive model can be broadcasted back to the sources, okay? So it's a generalization capability and absence of bias. So that's important as well, that we have this idea of personalization of the medicine. But on the other hand, it's possible that have general models that, let's say, can input. So we can input models and we can input data. So let's say we can, let's say, combine so that data science experts, AI experts can contribute as well. And the benefit is that the federated learning leverages from multiple data providers, okay? There's a minimal degradation from a centralized manner, but of course, this is a way to scale up. This is a way to avoid security breaches. This is the way that we avoid that it's allowed to a Microsoft cloud, and then we don't know where the servers, our data is stored, who is using the data. And of course, let's say that it's possible to train and follow the same AI rules. And this is something that as well is encouraged by the European Commission in the new rare disease partners. Okay, let me give some example of results. It's just you know, it's just the opening of many of the results we'll present it in the specific webinars, but maybe with some examples of results. Okay, you have some ideas that what we are doing, but what to do, and okay, what are we doing for the better care? Okay. So first of all, let's say that going to, or maybe I can go to the results, and then I can explain you how to be an associate member. Okay. Okay. For instance, okay, in MDS, for some multi-omics analysis that we did, so we were able to integrate the RNA sequencing data, transcriptome, into classification and prognosis in MDS. And let's say with clinical NGS sequencing expressed released by the GenoMed partners, okay, we're able to continue the analysis of the multi-omics and find really how to integrate all together. Okay, that's something that started 10 years ago, but let's say that we are really advancing on how we can do this integration. Again, for instance, something relevant as well in the part that we are integrating with MDS is the part of how we can integrate. We integrated the multimodal analysis. Multimodal means that we integrate genomics, molecular data layers, morphological data, histopathological images, in a and the clinical information in a multimodal manner to learn from there. So we have the molecular profile data. We are able to get the diagnostic images, and then we are able to have a fusion of that information to get at the end patient beta stratification. Okay. So let's say that there is a way that as we are saying, not only using genomics, not only using imaging, not only using clinical, but we are able to integrate all together to get our results. Okay, so that's something that is there. Of course, as I say, the more details will be offered, but that's some of the ideas of what we are doing. Multimodal AI-based model. I'm focusing a lot on the multimodal part because it's multimodal part means we use genomic, radiomics, clinical information, multiomics, metabolomics, and some other information, not only clinical, let's say, data to get the result. Okay, with some NDS cohort, 409 involved, and with molecular histopathology and multimodal integration, as you may see here. The results are much better when we are integrating and fusing the information from what was the prior art. So, okay, something that I believe that is as well important, and this model is for MDS. It's let's say an example. I can be extended to many others of how things can be integrated together. Something that I told you about silent cerebral infarction in sickle cell disease. Again, it's using MRIs of the brain, and okay, it's not classification, but it's about segmentation of image, identification of let's say main radiomics feature and image characteristics, but as well mixed with clinical information and other information as well, the multimodal idea to follow and find it and correct me if I'm wrong, but this is something really tricky that, okay, it's something beyond what was done in the past, okay? We are in progress to this. And last but not least, but something that as well that we have been doing in the some frameworks for the prediction of genomic mutation in precision cancer. And okay, with different methods, what we develop is to get the let's say main features and XGB, and following with some explanatory analysis of the algorithms to get the value of the impact of the model output, and have a kind of semi-interventic tool that can help and guide the health research and physicians in the understanding and the prediction of the genomic mutations. Okay, let's say that. I was counting the number of publication and results, and they are huge. Not only in terms of number, but also in terms of impact. So I suggest you to, if you are interested in specific parts or in specific models and something, not only to take a look at publications, but also to interact with us, ask questions, say how, if you would like to contribute, we are really open. And well, if anything that is needed, of course, we are really open to discuss. How we are going to discuss, sorry, because maybe to get a step back in the onboarding. The onboarding is something that I would like to define. It's the following: how to become an associate member. First, what's our manifest? Okay, action 1 is to fight against the scarcity of data and fragmentation. National approaches are often ineffective because there are low number of patients per disease, and there the entities are not connected. So it's the personal effort of some of health researchers or professionals to really try to connect. But let's say that there should be something European. And in some cases, we need to have, let's say, all infrastructure to do so in the way that it's easy to input the data. It's easy to provide the data. It's easy to collaborate. It's easy to learn and get something. So we're advocating for the quality, data, and reliability. So the data quality and reliability is key. But if people need to calculate in their repository, in their information, in the databases, quality and something manually, it's a lot of time. But we have AI algorithms to help in the preprocessing of the information, data curation, and automatic analysis of the quality. So this is helping a lot to really contribute with data, high quality data. We need to push the boundaries of multimodal data pooling. So contribute to high quality data should be multimodal for clinical, multi-omics, radiomics, genomics, metabolomics, and real world data that are the prompts, fitness information, nutrition, environment, information from wearables, from nutrition, as I say, the water intake, we have tools, fitness in the sense of, let's say, movement, not only, let's say, the sports, but as well, the natural movements, and you can start getting. So this is important to get a full-scale understanding for these diseases. And we would like to lead the way instead with the scaling up. Scaling up is fundamental. Scaling up the results in this distributed manner. Hospitals do not need to move the data from their sites. Okay, we provide a secure environment, trustworthy options if needed. If in the hospital there are not enough infrastructure, we will provide. No worries. With a minimal, let's say, hardware infrastructure, we can have the software infrastructure there and help. And we would like to build and nurture an active community, so offering access to a network of experts and researchers per disease, publication, funding opportunities, and clinical trials. All together, we are stronger. And this is one of the parts that I think that with EuroBloodNet, we can build something better. Better for who? Better care for the patients. We would like to engage with new clinical sites, and maybe the question now that happened to me in some of the meetings I had is, okay, what's your value proposition? Okay, what we are getting there. First, an AI sandbox. Models, algorithms for rare hematological diseases already tested, already working, open. Okay? Open means that you can extend, you can improve, you can adapt, you can do whatever. Visibility. Okay. As well, we would like to showcase the associated members, the expertise, contacts, etc., in the sense of, let's say that it's contributed and there, but the visibility, okay, it's not happening in the website. Fine. But as well the credit, the full academic credit, because we'd like to, okay, author publications where data plays a role, author with the knowledge and do it. And as well, we'll have to promote open science. So contribute to our European Open Science Cloud connection with metadata and aggregated data, okay? So let's say we're going to publish openly the data, of course, but the aggregated data for some studies and some insights. So general, let's say, publication can be done without disclosing, say, of course, the variables or anything or profiles are there. fully anonymized way of having understanding some of onboarding, going a bit more technical. Okay, so accountability, transparency, and usefulness of AI is key. We would like to build trust, not that say that you have a model, you don't know what the model is doing, just taking information, you know, sending a spy, software. No, but let's open the models, so we'll see what is going to be trained there, and everything is clear. So there's local edge, all premises, hospital, clinical site, clinical registry, whatsoever. We are going to have tools to extract, tools for data quality checks, to the pseudonym anonymize, and then we will train with the AI model. Okay, we are going to upload the parameters to a central server. Parameters out of the training, for example, the weights of the neighbor or coefficient for regression, or you know, or a cluster size or something, but never the data. So then the data manager and the model manager will collaborate together to have a general model aggregation, in the sense that as we have the parameters, the weights of every network, we will communicate there with the next clinical site. We are going to do the same. And with the next clinical site, we're going to do the same. So this update of the local parameters, we improve the model, okay? And with the improved model, we're going to do send this here, send this there, send this there. And this is exactly with 3 sites. Can you imagine with 100 sites, the power of AI there? So that's what we want to offer everybody with the model, and even the model adapted to the local data. And even the cases we need to think of that may be, even the cases per country have some sociological differences, or different, let's say, not exactly the same cohorts and data. So they have some peculiarities. So we should be able to cover so. So there are functionalities that we are going to provide. There's an open platform, AI workspace to train and test your models if you like to develop, or you have your own models. Let's say algorithms to train, or to learn, or your statistical framework. It's fine. And we can do the testing, because in the platform is able to let's say test, but even to train. The platform that we will offer, as I say, in one of the training sessions, more, let's say, more dedicated tests, and of course we will offer openly. It's preparative with a UI, with user interface. So let's say health professional can select the models and train. So you don't need to be best experts in IT, have IT knowledge to really work, and we offer the support and the let's say IT part. Okay, so let's say we can validate the models, get the resulting parameters, secure federated access control. In the platform, you can explore the list of available models in the registry and view the logs of the learning task. So let's say you can take one algorithm, one model, one statistic model, training with your data, train with the rest of the data of other clinical sites, get the results, parameters, retrain, check the models, and select different models to compare. So let's say that will be really nice, because you can have your own model, all the statistical model, all AI model, but also compare with others that are added in our platform. Contributing data. You have different data categories: demographic data, age, sex, ethnicity, height, weight, others, clinical parameters, diagnosis, treatment plans, medication, history, clinical trials, others. We have the laboratory parameters, imaging data, MRI frequency, collection frequency. Genomic data can be GWAS, annotated one. Genomic data can be even raw in NGS, microarray, or copy number variations. So there are different ways of doing. Biobank samples, point of sequencing data, other. So there are different data categories to contribute. Okay, of course, on the disease, more or less kind will be required. But let's say that there's different categories, as much as possible, let's say, contributing bad for the there. But one is that in our federation that's available, of course, some of them are more or less relevant depending on the disease. For the onboarding process and timeline and the steps, we have the online form application. So let's say you need to go with institution name, select the PI, data sets that you may contribute, data formats, and consents that you may have. Then the two will do the evaluation, let's say the data assessment with relevance, scope, and quality, and we'll check consensus and additional clarification. Okay. Once that is done, and let's say that reads something that can be contributed, let's say with reasonable manner, and we complete this assessment. We'll sign an agreement with legal considerations that we already prepare, and with the tools that we'll provide will be provided. And the step 4 will be preparing the data with the data dictionary, specific data provisions, and then we'll connect to our federation. The onboarding will be complete, and from there we can start with the considerations that we discussed in the past, let's say, slides that I was commenting about the publications, testing, going to open science. Okay, in a way that the onboarding is complete, and then you are part of the GenoMed4All family, but also as well of the, how to say, of the, let's say, EuroBloodNet research model of collaboration future. And that's something that I encourage you that are attending, or anyone that you may know, to explore it if we can reach good understanding. Fine. If finally there's something missing, no worries, because let's say that for sure in a near future we will be able to collaborate. But again, if we're talking about rare diseases, okay, fragmentation is not nice, and let's say that the GenoMed4All is providing you many tools, IT tools, platform, infrastructures, knowledge, all the clinical sites with data structure, and that's an opportunity to continue and get more and more and better results in that area. So as I said, I gave, let's say, the introduction and some of the key results we got, as well how to collaborate, as well as some of the detailed information of the use cases. But in the next taking actions, we are going to cover the AI part in a more, let's say, in a stronger manner, as well on the platform, as well on the specific diseases and let's say the provision of results, etc. And that's something that is relevant, as well as the legal framework, and something that I would like to let's say to encourage your participation. And okay, say follow us on our website, and as well in Twitter or X, as well in LinkedIn. And more easily, you can contact us by mail or whatever mean. We are really glad on, let's say, contacting and having support and, let's say, exchange ideas with you. Thank you very much, and I try to keep it within the original schedule of 1 hour. And now it's the time for questions you may have. And that's all. And of course, thanks to our to give me the opportunity to be able to explain what we did, what we have, and what are going to provide now and in the future. Thank you very much.
Thank you very much for your speech. That was excellent. It appears that we've received a number of questions. So in a few seconds, we're going to switch over to the Slido so we can look at those questions, and then you'll have a chance to answer those. So first, anonymous question: how can we participate in the project?
Well, as I was commenting, the easiest manner is to follow our onboarding scheme. And let's say through that, we get into contact And let's say there are two ways. One, if being a clinical provider is to, let's say, be part of the clinical network in two terms, or providing data or knowledge. That's fantastic. And with this onboarding process that can be as fast as possible. That's one that it's possible to be done. Thinking in this project, and of course the umbrella of projects under the EuroBloodNet environment. Second, as I said, work with the data and provide algorithms as well. It's as a way to participate in the project. Both ways, clinical research or something, are to let's say with the onboarding let's say scheme that we defined, and it's available in the project website, or let's say you can contact through the contact email, and we will provide you that information as well. For anyone likes to look for more information or discussions, as well for patients, and to know, let's say, some of the results. We have the toolkit, let's say the resulting the completion of results that we'll say we are gathering, and of course this is something that we will be able to have in our newsletter, and information we will provide as well. So the participation from all these kind of let's say profiles is always possible, as I'm saying. Onboarding site with onboarding procedure to explain. I understand this will be available later. As well for the results, we will have a results toolkit to as well communicated to anyone interested. So please join in our information that we have there on website, or you can contact me, whatever, and we do the process, of course.
Great. Thank you very much for your answer. Next question, and feel free to choose the question that you want to answer given any kind of time constraints. So please let me know. Next question is, good morning. Any projects ongoing or starting in the homeostasis? I'm
not sure exactly if there can be projects. Maybe I don't know if someone in the let's say EuroBloodNet can help me with that, but if not, I can check exactly within the framework. I don't know if you might know a bit more on this.
Yeah, hi. Well, we don't have now any concrete one on the level of maturity in the scope of the EuroBloodNet, but we are discussing with the coordinators for bleeding and coagulation, and we have something on the pipeline for some bleeding disorders. So if someone is interested on it, perhaps can drop an email to the coordination of the ERN, and we can discuss it.
Great. Thank you very much for your answer, Mar. Proceeding to the next question, what is your experience in using AI for early lab diagnosis, for example, detecting and flagging abnormal blood parameters and referring patients to hematology?
There's I don't know exactly in the consortium, but the next webinar that is more about AI, I can, let's say, refer to this, let's say, AI for early lab diagnosis. What I understand is that, let's say, all these, the parameters are collected, finding abnormalities, let's say, is one of the aims from the studies that, let's say, we are, let's say, doing for some of the diseases. So one of the AI aims is to, let's say, find out, let's say, the variables or the collection of parameters that are not corresponding to the, let's say, to the normal one, and are more parameters that are related to some of the diseases. It's true that the patients that we have are already diagnosed, but in that case, there's part of the of course, can be part of the AI. That one of the parts of the AI is to start by, let's say, flagging or understanding, or let's say, predict with models that are relative to a normal, let's say, parameter count in some of them. So that's something that maybe can be a bit more covered in the next one. But what I understand is that something that, for example, can be done. Talking to me personally, I can ask, but I'm sure that this part in the AI, it's part of the studies.
Okay, thank you very much for your answer. Do you plan to extend the project to other rare diseases like TTP, for example?
Was one of the topics discussed in the DHA EuroBloodNet session in 2023. And there's a plan ongoing from there. I can explain, but maybe since the plan was triggered by Mar, maybe she can better reply.
No, you can explain, go ahead, but it's linked to the previous question about the hemostasis, so maybe we can elaborate a bit more if there is interest on this field. So, well, yes, it is linked to the previous question. So there is some idea for expansion, and as I said before, we are discussing with the coordinators, that is Professor Flora Peibandi and Professor Sophie Sussen as coordinators in the ERN-EuroBloodNet. They have a lot of experience and some national approaches, and we had some discussion to expand and to replicate the model for some bleeding disorders, and there is a concrete idea also for TTP. So we had some discussions last year. I don't know if you want to add anything, Federico, more from the technical part, but
no, that's something that okay, more than a technical part is that that's okay, that's in the pipeline. Let's say that we started with these 3 cases, okay. Then in other projects in the EuroBlood area, like Impact EML or Syntema, we are dealing with AML, okay, and some other projects are dealing with other diseases, and one of the advances, as we said, with Flora, it's exactly the TTP. So of course, this is one of the, let's say, on the pipeline or umbrella is really to let's say grow. So the algorithms that we are doing are able to have an impact as well in other diseases such as TTP, for instance, where the scarcity of cases is
perhaps something important that you also show in your slides, Federico, is all the standardization of the hematological data that we are working a lot on it, no? Through the enroll, RADIP, and all the different use cases. But what is important is that all this effort that we are doing in hematology that can be scaled up to other hematological diseases quite not easy, but is easier not to be expanded than for other hematological disorders that will be sharing many of the parameters that are needed for the algorithms.
Great. Anything else to add? If not, we can move on to the next question from Monica. Thank you very much for your attendance, Monica, and your question. Could you please send contact on associate members access?
Okay, yes, of course. I'll know what is the best. I understand that you have when you have the contacts of those that let's say applied or enrolled or let's say just registered to the webinar. So yeah, we can send the contact and and forms and information and maybe a specific slide set so you can take a look, and the person that is on the onboarding process is coming back in exactly 12 days. So let's say that in 12 days we can start with the interaction and everything there. But yes, of course, let's go.
Okay, I'll make a note of that. Thank you very much. And following question, can the model be used to predict relapses?
One of the aims, one of the, let's say, aims of some of the models, not only to work with cross-sectional data, as well to work with longitudinal data. Working with longitudinal data, we're able to define these patterns. And one of the, let's say, studies that we are doing and we're examining in some of the diseases, for example, checking with in sickle cell case that some of them have, let's say, even 20. So let's say that there are many ways that let's say that we are, let's say, examining in a longitudinal manner what will happen in the next years. Something is complicated, but it's something that the models can be able to predict and stratify patients that are more able to predict the relapses when they are going to happen. It's a bit more complicated, of course, but let's say that all this is part of some of the AI models. I need to check, but I think one of the publications is covering that part. I can send it later. But let's say that is in the studies that we are examining. I think one of the, even in the study of the MDS, if I'm not wrong, this is one of the parts of the studies that we. This one of there. I can show you I don't know if I can show you in the chat. Also, maybe Mark can talk a lot about some of the studies we did. But in one of the first of the studies was doing increase of disease relapse probability about post-transplantation. So let's say that just you can take a look. I don't know, Mark, maybe you can comment a bit more on the clinical viewpoint.
Well, yes, I think that this question is more for the MDS and the oncological diseases, but I think the answer is a bit the same. So firstly, we are working more on identifying risk and to predict and to develop models for risk scores. But then the next step is to predict what will happen, of course, yes. So, and as Federico said, we are also collecting this longitudinal data in order to be able to do so, because at the end, of course, what we want is to be able to predict what will happen, no, and to have some prognosis scores. But I encourage the participants to register to the specific webinar for each disease, because then you will have the experts for the different conditions and more all what we are doing. So for the next webinars, you will have more details on all the results and what has been achieved so far.
Yeah, I added there in the chat one of the examples of the publication calculating the relapse risk for post-transplant. Okay, that's one example of MDS, but yeah, there are, let's say, the key is the use of longitudinal data.
Exactly. And then for the non-oncological, also in a similar way, no, we also aim to develop these scores to predict the risk for some of the severe acute complications in the patients.
Great, thank you both for your answers. We'll move on to one of the last Slido questions, and obviously there's still time remaining, so if anyone wants to speak up or put a question in the chat, feel free. Last Slido question. Sorry if I missed it. How about the explainability of the models? Can you retract a prediction to the source that led to that prediction? For example, a specific mutation?
Well, that's okay. Coming back to something relevant. AI models are criticized because of in some cases, lack of explainability. And that's fine if you would like to generate an image. Not that, no, like all of this generative AI that generate text, no, like ChatGPT is fine, but in health this cannot happen. Maybe you're not interested in how ChatGPT is producing the results, but in health is not the case. So we cannot, let's say, take decision without knowing exactly why they are taking. And why they are taking is the white box that we say. So exactly the explainability of the models is done by some tools that where they are saying or where they are explaining is first of all, the importance of the variables to take the decision, okay? Second, the process and why it is taken. For example, you are commenting, it was a specific mutation, it was more important the environmental factor, or about the full set of variables is 80%, not 80% exactly, but the more important are the mutation, the environmental factor, and the age. We need to know that. We need to know that, as we did in the past with statistic analysis or with machine learning, like the clustering or the progressions that are very explainable, or the hypothesis contrast. So the important part is that we are able to, let's say, explain the results. If not, I think black models are very interesting for other sources, other uses, but not for health. So all that we are doing, it's about providing the model and the explanation. That should come together. Even in the new AI Act in the European Commission, let's say you need to provide explanation, and that's key, and that's what we are doing, and that's full known to know exactly why and which are the main parameters leading to that decision.
Great, thank you very much for that response. I'd just like to take a moment on behalf of GenoMed4All and ERN-EuroBloodNet to thank you for your attendance and participation and all the questions. We're very much looking forward to the remaining webinars, and it's been a true pleasure. Thank you once again, Federico, and thank you, Mar, and thank you everyone that's attended.